Hello everyone. I'm going to go over with you how to determine what your hypotheses are so that you can know which kind of tails your test will have. And I'm also going to touch on how to know which symbols to use for a parameter and different scenarios for examples. So let's start off with just discussing a few things that we need to know about setting up a hypothesis test. The first thing is that when we're determining whether we'll have a two-tailed test, a right-tailed test, or a left-tailed test, we will look at the symbol of the alternative hypothesis. Right? So to determine the tails, look at the symbol in the alternative hypothesis, which we denote as HA, or in this textbook it's H1. They're just two different ways of denoting the same thing. So looking at an example where we have an alternative hypothesis with a symbol like this, that would be a right-tailed test. With this, it would be left. And with this, it would be two-tailed. Okay, so that would look like this, where you have one positive critical value and your significance level alpha is entirely on one side of your curve. So for instance, if we assume that alpha is 0.05, then for a right-tailed test, you would have 0.05 entirely on one side of your curve. And for a left-tailed test, it would be just the opposite. So you would have your entire alpha in one tail on the left, and you would have one negative critical value. And then for two tails, you would actually be splitting up that significance level into two tails, where you would have a negative and a positive critical value, and that alpha would be halved on each side. Okay, those are the scenarios you can have, and so the types of tails you can have are right, left, and two tails. And that is always based on the symbol in the alternative hypothesis, and the alternative hypothesis can only have one of these three symbols. So the alternative hypothesis should never contain the condition of equality. So you can never ever use this symbol, that symbol, or of course the equal sign for the alternative hypothesis. All right, so that's how we know the types of tails. Now let's talk about the null hypothesis, which is our default assumption. So when we do a hypothesis test, we're trying to see if we have significant evidence to support rejection of the default assumption. All right, so the null hypothesis H sub 0 always assumes equality. We are assessing whether our test statistic, meaning the sample statistic that comes from our sample, is extreme enough that we can assume the result did not happen by chance. In other words, it's a significant result. And if we find that to be true, then we will reject the null hypothesis. When doing a hypothesis test, we are always deciding whether to reject H sub 0, the null hypothesis. Right? That's important. All right, so now let's talk about how to determine how to state your hypotheses based on your claim. So let's do some examples. And before I get started, let me give you one more thing to keep in mind. The claim, if it has equality in it, such as this sign, this symbol, or this one, then it becomes the null hypothesis. Even though we won't use, let's say your claim has this sign, that does not mean that we're going to use that sign in our null hypothesis, because the null hypothesis, or I should say, always use the equal sign in your null hypothesis statement. Always, always, always. Okay, so this would not be correct. Even though if your claim, like this, could be wording such as, test the claim that the proportion of people who know Twitter is no more than 50%. So that would be a claim that you could write as the proportion of people who know Twitter is less than or equal to 0.5. Now that is a claim that contains the condition of equality, so it would fall under the null hypothesis. However, we will only use the equal sign. Okay, now, when that happens, the alternative has to be the complement of the claim. Okay, so like in the example I gave you, if the claim was that the proportion is less than or equal to 0.5, the null hypothesis would absorb the claim, and since the claim is accounted for in the null hypothesis, and you can't have the claim be partially in both hypotheses, then your alternative hypothesis has to be the complement of the original claim. Okay. All right, so let's talk about more possibilities that could happen. Okay, so that was the situation where your claim contained equality. What if your claim does not? Or you could just say strict inequality. Let's put it that way. Strict inequality, such as this symbol, or that symbol. Then your claim goes straight into the alternative. And your null hypothesis will always use that equal sign no matter what the case. So let's try some different examples, different scenarios that could come up. Okay, so example 1 I gave you already. If the claim is that no more than 50% of people recognize Twitter, then the null is always equality, and it actually absorbs the claim. The alternative is the complement of the claim. Okay, so that's one scenario. Let's change it this time to another scenario. Let's say there's no equality in that. Then your claim actually falls directly into the null hypothesis. I meant to say the alternative hypothesis. And this remains as it always will be with the equal sign. Okay, so that would be a left-tailed test. All right. Let's just back up again to example 1. We had this here. We had to turn around the symbol of the alternative. So that would have been a right-tailed test. As soon as we say we're not going to allow even equality of 0.5, then the alternative is the exact same as the claim, and that is a left-tailed test. So you got to be careful. All right, let's look at another example. What if the claim was that exactly 50% of people know what Twitter is? Okay, so this time again, the claim contains equality, so it gets absorbed into the null, and the alternative will be the complement of the claim, and that's a two-tailed test. And that would have been example 3 so far. Now let's try another one. Example 4. Let's say you have a claim that the proportion is not equal to 50%. So the claim doesn't mention whether we think it's above or below, just that it's not equal to 50%. In that case, your claim falls under the alternative. Now, why does it matter where your claim falls? That we will discuss when we talk about final conclusions of a test. So this is relevant, and you'll notice that on the form that I gave you to practice on, the hypothesis testing guide, the HTG form that I give you on tests, it has a section where you go through this process. You state the claim in symbols, then you state the null hypothesis, and you state the alternative hypothesis. And I also ask you to put in parentheses, just like you've seen me doing, where the claim is falling. So that's a key skill that you get points for on the test. And it's crucial because if you get this part of it wrong, the rest of your test will not be correct. All right, so that was 4 examples, all dealing with P. So what did I do? Let's see. Example 1, the claim was that P was less than or equal. And so this turned out to be an alternative like this, which means it was a right-tailed test. And then I did one where our claim was the strictly less than, which meant that our alternative was the claim, and it was a left-tailed test that time. So this one would have had a positive critical value, this one has a negative critical value. Then I gave us the claim that there's equality, and so the alternative was not equal, and so that gave us a two-tailed test. So these critical values will be different than the absolute value of these because we'll have smaller areas in the tails. Then we have the claim where we used not equal, then the alternative used not equal as well. And again, we had the two tails. What about if the claim was this? If that was the claim, then the alternative would use the symbol less, and it would be a left-tailed test. Okay, got the hang of that. And what if the claim was P is strictly less, or strictly greater rather? Then the alternative would be, and it would be right-tailed. Okay, so how can we summarize all this? I would say, I think the simplest way to put it is, if your claim does not involve equivalence, it automatically becomes your alternative. And if there is equivalence in your claim, then your alternative is the complement. Simple as that. Now, I've only given you examples involving a claim about a proportion, but there are other types of tests we can do. So we could have a test where the wording says, test the claim that the mean number of, or the mean, I don't know, the mean IQ, how about mean IQ of adults is greater, I wouldn't use it like that, greater than 100. Okay, so the claim in symbolic form is not P this time, because P stands for proportion. That's little p without a hat on it, stands for the population proportion. This is a claim about the mean, mu. And it'll be greater than 100. That's the claim we want to test. Notice that whenever we do the claims in symbolic form, we never use the sample statistic symbol. So I'm not testing a claim about the sample mean being 100, because that wouldn't make sense. We're using a sample to determine whether we think a claim is true about the population. So we always state our claims with the population parameter symbols. So there's no equality in the claim, which means it becomes the alternative hypothesis. And as always, the null hypothesis use the equal sign. That's the null hypothesis. The default that we want to try to prove might be false in order to support the claim. All right, so let's do another example. What if we did greater than or equal? What happens then? Then the claim is actually covered by the null hypothesis, and the alternative has to be the complement of the claim. And so that would be a left-tailed test, whereas before it was a right-tailed test. All right, so that covers how to determine what kind of tails you have and how to state your hypotheses. And then we'll do another video where we expand on this and we start talking about why it matters where the claim is contained, whether it's in the null or the alternative. And we'll look at how to draw conclusions based on our test results.